All right, so we're starting our unit on factoring, and you probably have seen the majority of this chapter in Algebra 1, but some of it is going to be new and at a higher level. So we're going to start at the very ground floor basics, and everyone is going to want to have a calculator on their desk today, so make sure you grab that right now. What we're going to do is just talk about prime factorization, getting all the common factors out, and then on the next page we'll look at some algebra, but we're just going to look at numbers here. So most commonly, when you've seen these problems, your teacher has probably said make a factor tree. So we're going to start by doing that, but I'm going to show you a shortcut with your calculator so that you don't have to take up so much space. But just to kind of jog your memory here, when I'm talking about factor trees, I'm talking about what numbers multiply to be that number 10. Okay, so 2 times 5. So you would write your answer like this. Okay, 33, 3 and 30, 3 and 11, sorry. And 25 is 5 and 5. Now when you write this, you're going to write it as 5 squared. Okay, I would also accept 5 times 5. In fact, why don't we go with that route? We'll just list all of our numbers here. All right, so if we were going to do 980, this factor tree would get a little bit larger, which is fine. And if this is really how you think about factoring, you're more than welcome to do factor trees. On the worksheet today, there's just not a lot of room for them, so you'll have to maybe get out a scratch piece of paper and then make your factor trees. But what I like to do is to use the calculator. So we do have to know our divisibility rules. Okay, the main one being if it's even, you can divide by 2. And then if all of the digits add up to something divisible by 3, it's divisible by 3. We'll get to that in one of these examples here. If it ends in 5 or 0, it's divisible by 5, things like that. So we start with the smallest numbers first and we divide until we can't divide anymore. So looking at 980, if we have our calculators on, we're going to take 980 and we're going to start dividing by 2 as many times as we can, okay, and write them down as we go. So we go 980 divided by 2, and we get 490. So we divided by 2, so we're going to write that down. Now the next number in your calculator, which is 490, is also divisible by 2, so we hit divided by 2 again, and we write down that we divided by 2. Now the next number is not divisible by 2. It says 245. Okay, so next number we would check would be 3. So we take 2 plus 4 plus 5. What is that? It's 11. That's not divisible by 3. So this is not something that's divisible by 3. The next number to check would be 5. Okay, so 245 is divisible by 5. Okay, so we're going to hit divided by 5 and write down that we divided by 5. And then the next number is 49 on your calculator. Okay, at this point you should be able to just say what the two factors are, hopefully, which would be 7 and 7. Okay, so this would be the prime factorization, all the prime numbers that multiply together to be 980. Again, you can use a factor tree to do that. These would be all of the ends of the branches on your tree, the 2, 2, 5, 7, 7. But I seem to find this calculator way a little bit better and faster. All right, so the next one, 18,900. So we put that in the calculator and we start dividing by 2 as many times as we can. So I did once. The next number is also divisible by 2, so I do it again. But now it isn't. Okay, but we are going to check if it's divisible by 3. So the number is 4,725. So if we add those numbers together, we get 18. Is 18 divisible by 3? Yes. Okay, so our original number of 4725 should be divisible by 3, and it is. We don't get any decimals or fractions. Okay, so the next number, when you add the digits, is also divisible by 3. So we can hit divided by 3 again. 525 is divisible by 3, so there's another 3. But 175 is not divisible by 3. Okay, so we can't divide out any more 3's. Here's another way to know this. If you get to a number and you hit divided by 3, if you do that on 175, you get a repeating decimal, okay, which means it doesn't work. So we go back to 175 and we can divide by 5. And then we get 35. 35 is just 5 times 7, so we put 5 times 7. And there's the prime factorization of 18,900. So that's going to be the first part of your worksheet today. All right, so let's get into what the algebra is going to look like. All right, so on these, you're wanting to think about undistributing. So when you distribute something inside of parentheses, you're multiplying it by both things. So when we undistribute, we're dividing. We're trying to take out what's in common with the algebra that's here. So looking at this first one, we have 2 terms. We want to take out what's in common with both. Okay, so looking at both of them, they both have an A and they both have a B. So let's take out an A and a B and write what would be left over if we divided by A and B. So on this first term, if we take out an A and a B, we're just left with a single A. On the second one, the second term over here, we take out an A and a B, we're left with B. Now if you do them right, what's left in the parentheses should have 0 things in common, because we took out all of those things that were in common. Looking at the next one, we want to take out as much as we can when we do these problems. So looking from the first term to the second term, there's no numbers that are in common because there's a 2 on one and a 1 on the other. But there are some x's in common. In fact, there's 2 x's that we could take out. So x squared, we can take out of both terms. So if we do that, we're left with this 2, the coefficient, and then one of the x's is still there. And on the second term, when we take out x squared, we're just left with y. Okay, looking at this next one. Again, you want to take out as much as you can. So looking at the 4 and the 6, what is the biggest number that we can divide out of both of those? It's 2. Okay, how many r's can we take out? We can't take any r's out because there's only an r on the second term. How many s's can we take out? We can take out at the very most 1 s, because there's only 1 s to take on the first term. And then we've got a t on both terms as well. So if we take those things out, we divide those things out of the terms, we're left with a 2t on the first one. If we divide by 2 on the next one, we're left with 3rs. And everything else was taken out front with that 2st. And notice these 2 terms in the parentheses have nothing in common now because we've taken all of that out. A couple more. Looking at this one over here on the left, looking at just the numbers first, we can divide both of those by 2, so we'll take a 2 out, not a parenthesis. What variables can we take out? Okay, so it looks like there's a u on both of them. Looks like there's a v squared on both of them. And we can't take a w out because it's only on one term. Okay, so when we do that, we're left with 2, and then only the w is left, minus u. Okay, this next one, we want to take out as much as we can. So we can divide all of those coefficients by 5. So we'll take a 5 out. How many x's can we take out at the very most? Only 1. How many y's? Also 1. And we can't take any z's out because it has to be in common with all of the terms listed. And it's not. Okay, so if we do this, remember we're dividing, we're not subtracting. We've got 3, we still have an x there, minus We divide, so we got 5 z squared plus, and then we divide again, so we got 4, and we take an x and a y away, leaving us with just a y. All right, last one. Looking at the coefficients, there's no numbers we can take out because there's a 12, an 8, and then a 1. So there's nothing in common there. How many a's can we take out? Looks like just one a. How many r's? Looks like we could take out 2 of them. And how many s's? None. Okay, so now all we need to do is take out an a and an r squared out of all of these terms, which means we got 12s cubed. We've got 8. We still have one a. The r's are gone, and we have an s. And on here, we're going to take away an a and 2 of the r's. So we're just left with 1 r. So that's all we're going to be doing right now. We haven't even really gotten into the meat of factoring yet, but this is really the first step on every single problem you're going to do for the rest of the chapter, is taking out this GCF. Always going to be your first step on every factor problem, chapter 4. So we need to get used to it.